We're in section 4-1, and we're going to deal with systems of first order equations. Differential equations. So that's what we're going to do. And we're going to go right to solving problems. So we're going to look at problem number 18. If I can get there. Number 18. And I have y prime is equal to x. And I have x prime is equal to y. Well, let's see. So if that being the case, then I'm going to use this guy, and I'm going to say, well, y double prime is equal to x prime. And but x prime is equal to y from the second equation. So that means that I'm going to have y double prime minus y has to be 0. How convenient. And now we can go back to chapter 1 and say I have a characteristic equation, and it's m squared minus 1 is equal to 0. I can say that m is equal to plus or minus 1. And I have that y of x it can be c1e to the x. There's a 1 sitting there. Plus c2e to the minus x. And so if that's what y is, then what is x going to be? Well, I guess we need to solve for x. So x is going to be y prime. What we're going to do is we're going to say that these are really t's. That would make more sense. Y of t to the minus t. And then x is going to equal y prime. So x of t is going to equal c1e to the t minus c2 e to the minus t. Okay, final answer for y of t, final answer for x of t. All right, moving on to the next guy. Number 20. I have x prime is equal to 10y, and y prime is equal to minus 10x. And I think I have initial conditions. X of 0 is 3, and y of 0 is 4. Okay, so I'm going to say I'm going to take the top equation and say that y is equal to x prime over 10. And then I'm going to say that y prime is going to be x double prime over 10. And then I'm going to say, well, x double prime over 10. And then I'm going to plug that back into this equation and say that x double prime over 10 is equal to minus 10x. And I'm going to end up with x double prime is minus 100x. Okay, one more time. X double prime plus 100x is equal to 0. Now I have a characteristic equation. Characteristic equation, m squared plus 100 equals 0. Implies that m is solution set plus or minus 10i. So x of t gets to be c1 C1 cosine 10x, C1 cosine 10x, 10t, and plus C2 sine 10t. All right, we'll apply an initial condition. X at 0 is 3. X at 0 has to be 3, which implies that C1 is 3. Okay, so I've got x of t is equal to 3 cosine 10x, 10t, plus C2 sine 10t. Okay, looks good. And I'm going to go with x prime now and say, well, what is x prime? X prime at t. Minus 30 sine 10t plus 10 C2 cosine 10t. But x prime is also 10y. So this is also 10y. So I've got that y of t is going to equal minus 3 sine 10t plus C2 cosine 10t. All right, apply initial condition. Y at 0 is 4. Well, that implies that C2 is equal to 4. So final answers. Y of t is minus 3 sine 10t plus 4 cosine 10t and x of t is equal to 3 cosine 10t plus 4 sine 10t. Okay, and that checks with backup book. So that was lucky. Okay, number 21. Now, I don't know why I'm doing 21. Normally you guys get to do all the odd ones, but somebody in the past asked for problem number 21. So there might be something interesting about it, so we will just do it. X prime is 1/2 y, and y prime is 8x. Okay, well, this sort of implies that y is equal to 2x prime. Well, if I'd write down the right problem, I might have a better chance here. So y is 2x prime, and from that we know that y prime is 2x double prime. So we have 2x double prime minus 8x is 0. Which gives us a characteristic equation. And back to what I was saying before, the problem has a minus sign sitting right there. So I better put it in. And when I do that, make this a plus. So I have a characteristic equation, m squared plus 4 is 0, implying that m is plus or minus 2i. And x of t. X of t is equal to c1 cosine 2t plus c2 sine 2t. Okay, so we'll go with x prime. What is x prime? X prime of t minus 2 c1 sine 2t plus 2 c2 cosine 2t. And we know that x prime is also equal to 1/2 y. So y of t is going to be minus 4 c1 sine 2t plus 4 c2 cosine 2t. And I don't see anything particularly uninteresting about that or anything. That checks with backup book. So we'll proceed from there. Looking at number 22. x prime is equal to 8y. Y prime is equal to minus 2x. Okay, so I got y is equal to x prime over 8. I take the derivative of that and say y prime is equal to x double prime over 8, which is equal to minus 2x. Right there. Okay, well, that being the case, I can rewrite that and say I have x double prime plus 16x is 0. I have a characteristic equation, m squared plus 16 is 0. I have an m of plus or minus 4i. Oh, that looks bad, doesn't it? Plus or minus 4i. Okay, so x of t is going to be c1 cosine 4x for t plus c2 sine 4t. And I look for x prime. X prime is equal to minus 4 c1 sine plus 4 c2 cosine. And I have a whole lot of extra marks there. See if I can do something about it. It looks a little better. Well, that looks a lot better. Okay, and seeing that that has to equal 8y, then I got y of t is equal to minus 1/2 c1 sine 4t plus 1/2 c2 cosine 4t. And that checks with backup book, so we're good with that. Okay, one last one, and we'll be done with section 4.1, number 24. X prime is equal to minus y, and y prime 10x minus 7y, and I have initial conditions x of 0 is 2, y of 0 is minus 7. Okay, so we'll use this guy here first and say that y double prime is equal to 10x prime minus 7y y. And we're going to rewrite that as y double prime well, we're not going to do that. So what we're going to do is we're going to use this guy, and we're going to say that y is equal to minus x prime, which means that y prime is equal to minus x double prime. And then we're going to use that in this equation and say that minus x double prime is equal to 10x minus 7 times y, which is minus x prime. Okay. Now we come up with an equation that looks like 0 is equal to x double prime plus 7x prime plus 10. And right now it doesn't look too much like that, but if I had a smaller eraser, maybe I could do better. X double prime plus 7x prime. Okay, which has a characteristic equation m squared plus 7m plus 10 is 0. And I can factor that m plus 5, m plus 2 equals 0, and I can come up with m is equal to solution set minus 2 minus 5. And I really do want to write that in the other order because I like ascending order better. Minus 5 minus 2. So x of t is going to be c1 e to the minus 2t plus c2 e to the minus 5t. Now why did I write it that way? I don't know. Okay, I wanted to write it the other way, but that's fine. And then I look at an initial condition, and I say x of 0 is 2. So x at 0 is 2. So that implies that c1 plus c2 has to be 2. Okay, and then I look at x prime. X prime, which is equal to minus y from up above, if we don't remember, minus y. So I got x prime, I got minus 2 c1 e to the minus 2t minus 5 c2 e to the minus 5t. So I have y is equal to 2 c1 e to the minus 2t plus 5 c2 e to the minus 5t. And I have an initial condition. Y at 0 is what, minus 7? Which says that 2c1 plus 5c2 has to be minus 7. Okay, so that looks good. So we'll solve for C1 first. C1 is equal to 2 minus 7, 1, 5. And on the bottom, I've got 1, 2, 1, 5. 1, 2, 1, 5. So on the bottom, I have a 3. On the top, I have 10. Plus 7 is 17. So I have 17 over 3. And if C1 is 17 over 3, and C1 plus C2 has to be 2, then C2 had best be minus 11 over 3. So final answer, x of t equals 17 over 3 e to the minus 2t minus 11 over 3 e to the minus 5t, and y of t is going to be 34 over 3 e to the minus 2t minus 11 over 3e to the minus 5t, and that checks with back of book. Okay, and that ends section 4.1.